So multivariate linear regression, for this we are going to be using this data set, which is right here. I have opened it using this link, and let me just, okay, zoom it. So what it contains is, it is a data set. It contains about 10,000 rows, and the dependent variable here is MPG, which is miles per gallon. And the independent variables are how many cylinders the car has, the displacement, horsepower, weight, acceleration, model year, okay, in what is the model year of that car, the origin of the car, and the name of the car. So you can see this is the first data of the first car right here, okay, data of the second car. So that's why there are about 10,000 of these. And we are going to train our model to work with all these independent variables in order to predict the miles per gallon. Okay, and this is the file given. You can access this file from the link in the description box so that you can also code along. And these are the libraries, NumPy and Pandas and Matplotlib as usual. Later on, we will be using sklearn as well when we want to plot all these things. So I think by now you're already familiar with this part of the code, that is simply reading the CSV file and then printing the data frame, just about a couple of rows so that you know this is what is happening. Okay, these are the cars, getting cars and their details, and the miles per gallon, which is our dependent variable. Okay. Now that could be usually when you take up a project in data science or data analysis and visualization, there could be some missing data or unclean data that's not proper and doesn't make sense. So for such kind of data, you would have to first of all do some cleaning. Okay. Now, because we are not getting too much into data science, we want to do this with as little code as possible, which is why I have taken data sets which are not really that hard to clean. And up till now, we haven't even cleaned any of the data sets. But now this data set contains some empty blank values. For example, you can see there is this horsepower, which is missing for some of the records. Okay. And so what I want to do is remove such records, and that's exactly what's happening here. Did I run this code? Let me just run that code up. Okay. Now for this, first of all, in order to find these types of rows, you have to use this auto_df. Okay, because that's the variable in which we read all these things. So autodf, and once again autodf, we are doing it that way. Oh, right here. We are doing it that way because it is a two-dimensional array, and that's why we have to specify it twice. So we want horsepower, and we want to check if this double equal to question mark. Okay, question mark, which means it does not have a value. So that's what we are doing. Okay, so we are getting there. Now we don't just want this data, we want the index of such rows where this is happening. So that's why we've just added dot index to this thing. Okay, we've just added dot index. Let me run the previous cell first. Okay, so these are the values, and now we are just fetching all those indices by writing dot index to the same thing we wrote earlier, and getting all those indices into index names variable. And then we want to delete such. So to do that, you just have to use the drop function. So auto_df is a variable containing the CSV, and just write dot drop and pass the indices you want to drop. Okay, and we want it to be dropped in place. So it should not change once we have dropped one of the indices. So this is in place equal to true, and so it will drop all those indices. And now just to check if this has worked or not, first of all, let me run this. Okay, so let that cell, okay, that cell is done. Now to check whether this worked or not, we are going to do this this line which you see right here, we are going to do that line again. Okay, just to see if there are still any question marks available, any values which are missing in horsepower. So you can see as a result of this, let me run that. So as a result of this, you can see that I'm getting a table which has no rows, which means now there are no more question marks for horsepower. Okay, and the next thing we are doing is just assigning a data type, okay, to horsepower, okay, just to see the information. Okay, so we are assigning a data type float to horsepower. You can see here, right here. Okay, and if you do .info, then you can get all the data types for all your columns, which you're seeing here, the memory usage and everything. So you can see this right here. There are 9 columns. Okay. And now what do? We have to now specify our x and y variables in order to create our regression model. Okay. So in this case, x is going to be, we are going to use the iloc function once again, which we used for polynomial regression as well. So you're familiar with it. So we want all the values and the columns that we are specifying. We want all the rows, but the columns that we want are 1 to 8. Okay, because there are 9 columns, and as you know, we always start from 0. So there are columns from 0th index to the 8th index, and we are taking columns from the 1st index to the 8th index into x because those are independent variables. But the 0th column, the first column itself is mpg, which is miles per gallon, which we want to predict, which is why y is going to contain only the 0th column. Okay, so dot values just puts all those values into x and y. And then you can see the shape if you like. Okay, so let's run this. It's running fine. If you want to see, you can see the shape of x. Okay, it contains 392 rows and 7 columns, right? Sorry, it's not 10,000 rows like I said before, it's only 392 rows. Okay. Now, next we are going to do this. We are going to import all these things, right? We are going to import linear regression as usual, and also mean squared error, because this time we have to find that error, this mean squared error, when we plot a line. Okay, I've explained mean squared error, I think, in my video on linear regression. So you can see that, and we are also going to do some training and testing. So we are going to split our data set because it's slightly larger one than what we used earlier. So we're going to split it into training data and testing data. Okay, and now we have so to do that type of a training and splitting, we are going to do it this way. So you need to pass 4 variables. The first variable is x train. So this means all the values of x that will be all the values of independent variables that we will use to train the model. And x underscore test are all the values of independent variables that we will use to later on test our model. And similarly, we have y train and y test, y train for all values of y that we will be using to train the model, and y test for all the values of y that we will be using to test the model. And then we can split our data using this function right here. And then we will create an object of linear regression, as you can see here. Okay, and then we will use the .fit function in order to fit our data into it. So we will be passing here the training data set. So for training, we have x underscore train and y underscore train, which we are passing here, you can see. Okay, and let's run it. So as a result, I'm getting this, which means there is no error and the model is fine. So now we are going to try to predict using this model that we created. We are going to use this Honda Prelude right here. Okay, so Honda Prelude car, we are going to use that, and we are going to pass the values of cylinder, displacement, horsepower, weight, acceleration, model year, and origin. So these are the values we will be passing in this order. And you can see I've just searched for Honda Prelude over here, and this is the row that contains it. Okay, and its MPG, which is miles per gallon, is 33.7, and the rest of the values are already in the same order as required. So 4107, 4 is I think number of cylinders, 107 must be the displacement, 75 is the horsepower, the weight is 2210, 14.4 is acceleration, and where did that go? Yeah. So model year and origin is given also. So we just have to copy from 4 to 3, copy these values and paste them over here in np.array to create the array that we want and save it as trial data variable. And then we have to reshape it because we need -1, 7 because we need a two-dimensional array to pass it into the model. Okay, and once we've done the reshaping, we just have to assign the type float to that. Okay, and then we are ready to predict. So let me run this thing first, and then we are ready to predict this. So we are just going to do regressor.predict. Regressor is the model we created here. We're using the predict function where we are passing the trial data, which means we are passing the value of x to get the value of y. And if we run this, we're getting 33.06, and the actual miles per gallon is 33.7. So that's very close. You can see it's predicting quite well the miles per gallon given the car. And we could also go and predict maybe one more car. Let's see. Let's search for Mercedes. Okay, we have 3. So one Mercedes-Benz 280S, we have 300D and 240D. Okay, so I think let's go for 280S. And here the miles per gallon is 16.5, and the rest of the values I'm going to copy from here and paste them right here. And then you just have to run this code, and let's see the prediction. So it says 17.9, which is also quite close. Here it is 16.5. Okay, let's take one of the values from the bottom. Let us see Ford Ranger, which is right here. So let's take all these values. Remember the miles per gallon is 28. So let's paste all these things here. Okay, let's paste it and run it. Oh, okay. I pasted it outside the brackets. So let me just put it inside the brackets and let's run it. Okay, let's predict. So it says 29.3. The actual is 28, which is not so bad. We're not very far. So I hope you understood how you can do the predictions and how you can create a polynomial regression as well as a multivariate linear regression. So that's it for this video, and I'll see you in the next one. Thank you for watching.